This is a lesson video for 5-6 related rates, number 6. There's a camera watching a rocket launched. And so as they describe the situation, let's get a decent picture in there. We know the rocket should be taking off perpendicular to the ground. The camera is 2,000 feet away. That's a fixed distance. And the camera's not moving, so the camera's right here. Height is given by a position function, so I'm going to call this S because that'll be the height of the rocket. And they talk about the angle of elevation, so I need a variable to describe that angle from the ground to the path of the rocket. In other words, as the camera would have to change its angle in order to stay with the rocket. So let's go through and see what we're trying to find, or what the G is, what we're trying to get. If we do the PIG, what are we trying to find? We're trying to find d theta dt, the change of that angle, at the exact time of 10 seconds. The rate that that angle is changing at that exact time. What's fixed or what's not going to change or permanent is that the x is definitely 2,000 feet. There's no other numbers that they gave us that are really fixed. We do know how to get position, so the fixed function anyway, if you want to record that. The way we can always get position, or that S value, is going to be 50t squared. At a certain point in time, it'll be when the time is 10 seconds. And at that point in time, I think we can calculate a few things that will help us. At that point in time, we can do position at 10 seconds. Position at 10 seconds will be 50 times 10 squared. It'll be 5,000 feet in the air. We can also calculate a little bit more. We could even calculate that angle theta at that time. So at that time, tangent of theta will be 5,000 over 2,000, opposite over adjacent, or 5/2. So at that time, theta will be inverse tangent of 5/2. I would leave it that way as it's very exact at the moment, and when I need that angle measurement, then I'll use inverse tangent of 5/2 on my calculator to get it. I should also consider that I might need some other information from that tangent theta equals 5/2, and at least be willing to come back and go back to that. So an equation that relates my theta to my side length would also be the tangent equation. That's the one that's going to relate my two variables in general. So tangent of theta equals the opposite over that 2,000. And just to make my life easier, 2,000 tangent theta equals S. Again, not for anything other than make my life a little bit easier. So as I go to do the derivatives, so that I have, and I'm going to switch sides here, ds dt, how the height is changing, I'm going to get 2,000, and then tangent of theta's derivative is secant squared. And then I still need my d theta dt. I want to look and see if there's anything in here I don't have yet, so I can go calculate it before I start plugging in. I'm trying to find d theta dt, so that's going to be fine. I do have theta. I have a way of finding that at that particular instance. And ds dt, so ds dt I'm still going to need. So I think I need to come back to one of my fixed equations that S is calculated as 50t squared. And ds dt then, I am doing this in terms of time, so that's going to be 100t. So now I have what I need to plug in for that. So as I go to put this all together, instead of 100t at that instance in time, at exactly 10 seconds, ds dt is going to be 100 times 10, or 1,000. So ds dt at that exact instance in time is 1,000. I'll have 2,000. Now, secant squared of theta is going to be cosine squared, and then the reciprocal when you go calculate that. But we're going to have to do secant squared of inverse tangent of 5/2. And I'm running out of room here, so let me slide over. And then my d theta dt. So moving all this around and solving for my d theta dt, and take a minute to do all of that, pause the video, don't just write this down, or it's not really going to help if you're not going and making sure you can calculate this correctly with all that trig on your calculator. And then be sure you answer the question. So the rate of change of elevation 10 seconds after liftoff, the rate of change of theta at 10 seconds is, and this is 0.069, and we're in radians as our change unit and seconds as our time unit.